The General Dynamics F-111 Aardvark carries the distinction of being one of the most paradoxical aircraft ever to enter service with the United States Air Force. It was conceived as a revolutionary multi-role fighter that would serve both the Air Force and Navy, replace multiple aircraft types, and introduce technological innovations that would reshape tactical aviation. Instead, it became a cautionary tale about the dangers of asking one airframe to do too much while simultaneously proving itself as one of the most effective deep-strike aircraft ever built. The Navy rejected it outright. The fighter variant was a compromise nobody wanted, and the costs spiraled so far beyond projections that it became a political scandal. Yet in the skies over Vietnam, Libya, and Iraq, this ungainly machine with its side-by-side seating and swing wings delivered ordnance with a precision and survivability that caught everyone off guard. The F-111 was not the aircraft anyone asked for, but it became the aircraft that defined precision strike warfare before the term existed. The story begins with Robert McNamara, the Secretary of Defense who brought corporate efficiency thinking to the Pentagon in the early 1960s. McNamara looked at the procurement process and saw waste. The Air Force wanted a new tactical fighter bomber to replace the F-105 Thunderchief. The Navy wanted a fleet defense interceptor to protect carrier battle groups from Soviet bombers. To McNamara, this was inefficiency incarnate. Why develop two aircraft when one could do both jobs? The Tactical Fighter Experimental Program, or TFX, was born from this logic, and it was doomed from the start. The requirements were fundamentally incompatible. The Air Force needed an aircraft capable of supersonic speed at low altitude, able to penetrate Soviet air defenses and deliver nuclear weapons deep into enemy territory. The Navy needed an aircraft capable of loitering for hours at subsonic speed, carrying long-range missiles to shoot down bombers before they could launch their weapons. One mission demanded a small, agile airframe optimized for speed and maneuverability. The other demanded a large airframe with powerful radar and massive fuel capacity. McNamara insisted both services would use a common design, and the result was an aircraft that satisfied neither while costing far more than two separate designs would have. If detailed technical breakdowns of aviation design and the strategic decisions that shape them interest you, subscribe. There are plenty more aircraft worth examining this closely, and the stories behind these machines reveal as much about politics and compromise as they do about engineering. General Dynamics won the contract in November 1962, beating out Boeing in a decision that sparked immediate controversy and congressional investigations. The design that emerged was unlike anything flying at the time. Variable sweep wings were the centerpiece innovation, allowing the aircraft to optimize its configuration for different flight regimes. At low speeds and during takeoff and landing, the wings extended to 16 degrees of sweep, providing maximum lift and control. For high-speed flight at low altitude, the wings swept back to 72.5 degrees, reducing drag and improving ride quality in turbulent air. This was not a new concept. The Germans had experimented with it during World War II, and NASA had studied it extensively. But the F-111 was the first production aircraft to make it work reliably. The wing pivot mechanism was a masterpiece of engineering, using massive steel forgings and hydraulic actuators to move wings that weighed thousands of pounds. Each wing could be positioned independently if one actuator failed, though this created obvious control problems. The system added weight, complexity, and maintenance requirements, but it delivered on its promise. The F-111 could take off from relatively short runways and then accelerate to Mach 1.2 at 200 feet above the ground, a combination no fixed-wing aircraft could match. The fuselage was a long, sleek shape dominated by the enormous engine intakes mounted on either side of the cockpit. These intakes were quarter-round affairs, carefully shaped to provide smooth airflow to the engines across the entire speed range. At low speeds, auxiliary inlet doors opened to provide additional air. At high speeds, ramps inside the intakes adjusted position to slow the air to subsonic speeds before it reached the compressor face. This was standard technology for supersonic aircraft, but the F-111's intakes were particularly large because the engines were particularly thirsty. Two Pratt & Whitney TF-30 turbofans sat in the rear fuselage, each producing around 18,700 pounds of thrust, with afterburner in the early models. The TF-30 was a troubled engine, prone to compressor stalls if the airflow was disrupted, and in a combat aircraft that routinely pulled hard maneuvers and fired weapons, disrupted airflow was inevitable. More than a dozen F-111s were lost to engine problems, and pilots learned to treat the throttles with respect, advancing them smoothly and avoiding abrupt movements that might cause a stall. Later models received improved engines with better stall resistance, but the TF-30 never fully shed its reputation. The crew sat side by side in an escape capsule rather than ejection seats, another innovation that seemed brilliant on paper and problematic in practice. The entire cockpit section was designed to separate from the aircraft in an emergency, with rockets pulling it clear, a parachute slowing its descent, and airbags cushioning the landing. It could even float, making water landings survivable. This system had several advantages over conventional ejection seats. It protected the crew during low-altitude, high-speed flight when ejection seats were useless. It kept the crew together, which was valuable if they came down in hostile territory. It provided protection from the elements during descent. In testing, it worked reasonably well. In service, it saved lives, but it also failed in ways ejection seats would not have. The capsule was heavy, adding around 2,000 pounds to the aircraft's empty weight. The separation mechanism was complex, with pyrotechnic charges, hydraulic systems, and mechanical locks that all had to work in sequence. Several crews died when the capsule failed to separate, or separated but failed to stabilize. Pilots appreciated the protection it offered during low-level flight, but many would have preferred conventional seats that were lighter, simpler, and had a longer track record. The side-by-side seating arrangement was necessary because of the escape capsule, but it had operational consequences. Communication between pilot and weapons systems officer was easier when they sat next to each other, and workload sharing was more natural. Visibility for the weapons systems officer was better than in traditional tandem seating, where the backseater often saw nothing but the pilot's headrest. However, the wide cockpit made the fuselage wider, increasing drag and reducing internal fuel volume. It also made formation flying more difficult because the pilot sat to the left rather than on the center line, affecting depth perception when flying close to another aircraft. Every design choice in the F-111 involved trade-offs like this, and the balance was not always favorable. The Avionics suite was advanced for the early 1960s, centered around the AN/APQ-1-13 attack radar in early models and the AN/APQ-1-44 in later versions. This was a multi-mode radar capable of terrain following, ground mapping, and air-to-air search. The terrain following mode was the most revolutionary feature, allowing the aircraft to fly automatically at low altitude while following the contours of the ground. The radar would scan ahead, build a picture of the terrain, and feed commands to the autopilot to climb over hills and descend into valleys, maintaining a preset clearance height. The pilot could select clearances from 200 feet down to 100 feet, though flying at 100 feet above the ground at 600 miles per hour in bad weather required nerves that not every pilot possessed. The system worked remarkably well when it worked, but early versions were unreliable, and pilots learned to monitor it carefully and be ready to take over manually. A failure of the terrain-following radar during low-level flight meant an immediate climb to safe altitude, aborting the mission and alerting every enemy radar within 100 miles. Later versions were more reliable, and by the time the F-111F entered service in the mid-1970s, the terrain-following system was mature and dependable. Navigation was handled by a combination of inertial navigation system, TACAN, and later models added GPS. The inertial system drifted over time, requiring periodic updates from known checkpoints, but it was accurate enough for most missions. The Weapons Systems Officer had a moving map display that showed the aircraft's position overlaid on a map image, a significant improvement over the paper maps and stopwatches used by earlier generations. Target acquisition could be done using the radar, which provided accurate range and bearing information, or visually using the PaveTac targeting pod on later models. PaveTac was a revolutionary system for its time, containing a forward-looking infrared sensor and a laser designator in a rotating turret mounted in the weapons bay. The Weapons Systems Officer could search for targets using the infrared image, designate them with the laser, and guide laser-guided bombs with unprecedented accuracy. F-111Fs equipped with PaveTac could put bombs through doors and windows, a capability that was unheard of in the 1970s and gave the Aardvark a new lease on life as precision strike became the dominant paradigm. The internal weapons bay was another feature that seemed like a good idea, but proved problematic. Carrying weapons internally reduced drag significantly, which was important for an aircraft designed to fly long distances at high speed. The bay could carry 2 nuclear bombs or up to 4 conventional bombs, depending on the model and mission. However, the bay was not large enough for the variety of weapons the Air Force wanted to carry, so external hardpoints were added on the wings. Once you started hanging weapons on the wings, the drag reduction from the internal bay became less significant, and you still had the weight and complexity of the bay doors and their actuation system. The F-111 could carry a maximum external load of around 30,000 pounds on 8 wing pylons, though this was rarely done because it destroyed the aircraft's range and performance. Typical loads were more modest, perhaps 8 to 12 Mark 82 500-pound bombs, or a mix of bombs and fuel tanks. The F-111F could carry GBU-10, GBU-12, or GBU-24 laser-guided bombs when equipped with PaveTac, and this became the preferred loadout for precision missions. Performance was where the F-111 truly delivered, at least in the strike role it eventually came to dominate. Maximum speed was Mach 2.5 at altitude, though this was rarely achieved in operational service because it required a clean configuration and afterburner, both of which consumed fuel at alarming rates. More relevant was the low-altitude speed, where the F-111 could sustain Mach 1.2 indefinitely, in full afterburner or cruise at around 550 knots without afterburner. This made it the fastest low-altitude aircraft in the world, faster than dedicated fighters and vastly faster than other strike aircraft like the A-6 Intruder or A-7 Corsair. Combat radius varied depending on mission profile and payload, but a typical low mission, low-altitude penetration, low-altitude target area, low-altitude egress, could cover around 800 nautical miles without refueling. Adding external fuel tanks extended this considerably, and the F-111 was equipped with an aerial refueling receptacle for longer missions. Ferry range with maximum internal and external fuel was approximately 4,000 nautical miles, making it capable of transatlantic flights with minimal tanker support. Given its combat record and the compromises that defined it, was the F-111 a success or an expensive mistake that happened to find a niche? Knowing what we know now about how strike warfare evolved, could the Air Force have achieved the same capability with a simpler, cheaper design? Let me know what you think in the comments. The operational history of the F-111 began poorly and improved dramatically. The aircraft entered service in October 1967, and by March 1968, the first F-111As were deployed to Southeast Asia under the name Combat Lancer. It was a disaster. Of the 6 aircraft deployed, 3 were lost in less than a month, and the survivors were withdrawn. Investigations revealed problems with the terrain-following radar, structural issues with the wing carry-through box, and general immaturity of the design. The Air Force grounded the entire fleet, and it would be more than 2 years before the F-111 returned to combat. The grounding gave engineers time to address the most serious problems. The wing carry-through box, which connected the wing pivots to the fuselage and carried enormous loads, was found to have fatigue cracks in some aircraft. The entire fleet was inspected, and a redesigned carry-through box was developed and retrofitted. The terrain-following system received software updates and hardware improvements. Crew training was enhanced, focusing on the unique characteristics of the aircraft and the proper use of its systems. When the F-111 returned to Vietnam in September 1972 under the name Constant Guard, it was a different story. The aircraft flew 4,000 missions over the next 2 years, and the loss rate was among the lowest of any aircraft in theater. The F-111's ability to fly in weather that grounded other aircraft, to navigate accurately at night, and to deliver weapons precisely made it invaluable. The North Vietnamese air defense system was extensive and sophisticated, with surface-to-air missiles, anti-aircraft artillery, and MiG interceptors all working in coordination. The F-111's response was to fly too low and too fast for effective engagement. SAMs had difficulty tracking targets in ground clutter at low altitude, and the F-111's speed gave gunners almost no time to react. MiGs could not catch an F-111 at low altitude in full afterburner, and even if they did, the Aardvark could usually escape by accelerating and staying low. The standard tactic was to fly at 400 to 600 feet above the ground, using the terrain-following system, relying on speed and surprise rather than altitude for protection. Missions were typically flown at night, with the aircraft arriving over the target area from unexpected directions and aggressing at high speed before defenses could react. The F-111's most famous mission came in April 1986 during Operation El Dorado Canyon, the retaliatory strike against Libya following terrorist attacks linked to the Libyan government. 18 F-111Fs from the 48th Tactical Fighter Wing at RAF Lakenheath in England flew a 6,000-mile round trip to strike targets in Tripoli. The mission required multiple aerial refuelings, precise navigation over water with no visual references, and coordination with Navy strike aircraft attacking targets in Benghazi. The F-111s approached at low altitude under radio silence, climbed to medium altitude for the attack to allow their paved tack pods to acquire targets, and delivered their bombs with devastating accuracy. Several targets were destroyed or heavily damaged, including Muammar Gaddafi's compound. One F-111 was lost during the mission, likely to anti-aircraft fire, and its crew was never recovered. The mission demonstrated the F-111's unique capability to strike targets thousands of miles from its base with minimal support, a capability that no other tactical aircraft of the era possessed. The F-111's finest hour came during Operation Desert Storm in 1991. 66 F-111Fs from the 48th Tactical Fighter Wing deployed to Taif Air Base in Saudi Arabia, and they flew some of the most effective missions of the war. Equipped with paved tack targeting pods and laser-guided bombs, the F-111Fs struck high-value targets including hardened aircraft shelters, command bunkers, and chemical weapons facilities. The aircraft's ability to operate in bad weather and at night, when most other aircraft were grounded, made it indispensable. F-111FS flew only 3% of the strike missions, but were credited with destroying more than 30% of the strategic targets struck during the war. The typical mission profile involved flying at medium altitude, 10 to 20,000 feet, to stay above the worst of the anti-aircraft artillery while using the paved tack pod to find and designate targets. The F-111's radar warning receiver and electronic countermeasures suite provided warning of SAM launches, and chaff and flares could decoy missiles. Not a single F-111F was lost to enemy action during Desert Storm, a remarkable achievement given the number of missions flown and the intensity of Iraqi air defenses. The comparison with contemporary strike aircraft reveals the F-111's strengths and limitations. The Navy's A-6 Intruder was a superb all-weather attack aircraft with excellent range and payload, but it was subsonic and vulnerable to modern air defenses. The A-7 Corsair was reliable and effective, but limited in range and incapable of supersonic flight. The F-4 Phantom could carry a large payload and was supersonic, but it lacked the F-111's sophisticated navigation and targeting systems and could not match its range. The F-15E Strike Eagle, which entered service in the late 1980s, was faster, more agile, and more versatile than the F-111, but it could not match the Aardvark's range or loiter time, and its radar and targeting systems were comparable rather than superior. The F-111 occupied a unique niche as a deep strike specialist, optimized for penetrating heavily defended airspace and delivering weapons accurately in all weather conditions. It was not a dogfighter, not a close air support platform, and not particularly good at anything other than its designed mission. Within that narrow role, it was unmatched until stealth technology made a different approach possible. The variants of the F-111 reflected the evolution of the program and the different needs of various users. The F-111A was the initial production version, underpowered and plagued with technical problems. The F-111B was the Navy version, heavier and even more underpowered, and it was canceled after 7 prototypes when it became clear the design could never meet Navy requirements. The F-111C was an export version for the Royal Australian Air Force, with longer wings and strengthened landing gear for carrier operations that never materialized. The F-111D featured improved avionics, but was so complex and unreliable that it was considered the worst variant. The F-111E was a simplified version with some of the F-111D's improvements, but fewer of its problems. The F-111F was the definitive strike variant, with more powerful engines and compatibility with the PAVE-TAC targeting pod. The EF-111A Raven was an electronic warfare variant with the tactical jamming system mounted in a large pod on top of the fuselage, replacing the internal weapons bay. The Raven served with distinction in Desert Storm and the Balkans, providing radar jamming to protect strike packages. The FB-111A was a strategic bomber variant with longer wings and no provision for external weapons, operated by Strategic Air Command until the end of the Cold War. The Australian experience with the F-111 is worth examining because it lasted longer than American service and revealed both the aircraft's enduring value and its fundamental limitations. The Royal Australian Air Force received 24 F-111Cs starting in 1973 after delays caused by structural problems that required extensive modifications. Australia also eventually acquired 4 F-111As and 15 F-111Gs, former FB-111, as converted to the tactical configuration. The F-111 gave Australia a strike capability that was unmatched in the region, with the range to cover the vast distances of the Pacific and the speed and sophistication to penetrate potential adversary defenses. The aircraft remained in service until December 2010, far longer than any other operator, receiving multiple upgrades including new avionics, weapon systems, and structural modifications to extend airframe life. The RAAF developed tactics and procedures specifically tailored to the aircraft's capabilities, and Australian crews became extraordinarily proficient in its operation. When the F-111 finally retired, it left a capability gap that the FA-18F Super Hornet and eventually the F-35A Lightning would fill, but neither aircraft matched the F-111's combination of range, speed, and payload. Maintenance was a constant challenge throughout the F-111's service life. The variable sweep wing mechanism required careful inspection and lubrication. The TF-30 engines needed frequent maintenance and were sensitive to foreign object damage. The escape capsule system had dozens of pyrotechnic charges and mechanisms that required regular inspection and replacement. The terrain following system was complex and temperamental, requiring specialized test equipment and highly trained technicians. Hydraulic leaks were chronic, and the aircraft used 3 independent hydraulic systems for redundancy, which tripled the maintenance burden. Corrosion was an issue, particularly for aircraft operating in humid or maritime environments. Avionics components were cutting edge in the 1960s, but became increasingly difficult to support as manufacturers discontinued parts and modern replacements were not always compatible. Despite these challenges, maintenance crews kept the F-111 flying at respectable readiness rates, and the aircraft's mission-capable rate improved significantly over the years as lessons were learned and procedures refined. Pilot opinions of the F-111 were generally positive, with important caveats. The aircraft was fast, stable, and comfortable for long missions. The side-by-side seating made crew coordination easy, and the workload was manageable with a good weapons systems officer. The terrain following system was either amazing or terrifying depending on the pilot's confidence in the technology, but it worked well enough that most crews learned to trust it. The handling was unremarkable, not bad, but not inspiring. The F-111 was not an aircraft you threw around the sky for the joy of it. It was a professional's tool, optimized for efficiency rather than excitement. The most common complaints involved the engines, which required careful management and occasionally quit at inopportune moments. The escape capsule was both reassuring and worrying. Reassuring because it offered protection during low-altitude flight, worrying because it was a complex system with multiple failure modes. Visibility was adequate but not exceptional, particularly for the pilot, who sat far forward and had limited rearward visibility. Formation flying required concentration because of the offset seating position. Overall, pilots respected the F-111 for its capabilities and effectiveness, even if they did not love it the way fighter pilots loved their mounts. The legacy of the F-111 is complex and contradictory, much like the aircraft itself. As a multi-role fighter intended to serve both Air Force and Navy, it was an expensive failure that vindicated critics of McNamara's cost-cutting approach. The Navy got nothing useful from the program and eventually developed the F-14 Tomcat to meet its needs. The Air Force spent far more money and endured far more delays than 2 separate aircraft would have cost. As a deep-strike aircraft capable of precision attack in all weather conditions, it was a remarkable success that defined a new category of warfare. The F-111 proved that a properly equipped aircraft could find and destroy targets at night and in weather that grounded everything else, and it demonstrated that low-altitude penetration at high speed remained viable even against sophisticated air defenses. The terrain-following system, variable sweep wings, and integrated avionics suite were all influential technologies that appeared in later designs. The F-14 Tomcat used variable sweep wings derived from F-111 research. The B-1B Lancer was essentially a supersonic F-111 scaled up to strategic bomber size, with similar wings, similar mission profile, and similar strengths and weaknesses. The Panavia Tornado, developed by Britain, Germany, and Italy, was clearly influenced by the F-111's design philosophy and incorporated variable sweep wings and terrain-following capability. The precision strike mission that the F-111F pioneered, with pave tack and laser-guided bombs, became the dominant paradigm in air warfare. Every modern strike aircraft now carries targeting pods and precision-guided munitions as standard equipment, and the idea of delivering unguided bombs in daylight against heavily defended targets seems as antiquated as biplane fighters. The F-111 demonstrated the value of this approach before the technology matured enough to make it routine. The ability to put a single bomb precisely on target was worth far more than the ability to put 50 bombs somewhere in the target area, and this realization changed procurement priorities, tactics, and training throughout air forces worldwide. The F-111 retired from United States Air Force service in 1996, replaced by the F-15E Strike Eagle, which offered similar range and payload with greater versatility and lower maintenance requirements. The EF-111A Ravens retired in 1998, their electronic warfare mission taken over by the EA-6B Prowler and eventually the EA-18G Growler. The Australian retirement in 2010 marked the end of the Aardvark's operational service anywhere in the world. A few examples survive in museums, and they remain impressive machines even sitting static on the ramp. The long fuselage, massive intakes, and swept wings give the F-111 an aggressive, purposeful appearance that photographs well and hints at the performance that made it formidable. If you found this deep dive into the F-111's technical evolution and operational reality useful, a like helps more people discover these analyses of aviation history's most significant aircraft. Thanks for watching. Looking back from the perspective of more than 50 years, the F-111 stands as a cautionary tale about the dangers of requirements compromise and an example of how a flawed design can still achieve operational success through persistence and adaptation. The TFX program was misconceived from the start, asking one airframe to do jobs that required fundamentally different characteristics. The result satisfied nobody, cost far too much, and took far too long to develop. Yet the aircraft that emerged from this troubled program proved capable and effective in the role it eventually came to fill. The F-111 was never the multi-role fighter McNamara envisioned, but it became the long-range precision strike platform the Air Force needed, even if they did not know they needed it when the program began. The kills per sortie ratio in Desert Storm, the ability to operate when other aircraft were grounded, and the decades of Australian service all testify to the fundamental soundness of the basic design once the mission was properly defined. The technological innovations incorporated in the F-111 were genuine advances that influenced aviation for decades afterward. Variable sweep wings proved practical and effective, even if the added complexity was not always worth the performance gained. Terrain-following radar matured from an experimental concept to an operational system that saved lives and enabled missions that would otherwise have been impossible. Side-by-side crew seating improved coordination and workload sharing, even at the cost of increased drag and reduced agility. The integration of navigation, targeting, and weapon systems in a single coherent package established standards that modern aircraft still follow. These contributions are real and significant, even if the F-111 itself was ultimately replaced by aircraft that incorporated its lessons while avoiding its compromises. The question that haunts the F-111 program is whether the same capabilities could have been achieved more efficiently with a more focused design. If the Air Force had been allowed to develop a dedicated strike aircraft optimized for low-altitude penetration and precision attack without the weight and complexity required for carrier operations and fleet defense, would the result have been better? Almost certainly yes. Would it have been cheaper? Probably, though the development costs would have been borne entirely by the Air Force rather than shared with the Navy. Would it have entered service sooner? Given the delays caused by trying to satisfy two incompatible sets of requirements, a focused design would likely have reached operational status years earlier. The real cost of the TFX approach was not just the money spent, but the capability delayed and the missions that could not be flown because the aircraft was not ready. Yet for all its flaws and compromises, the F-111 succeeded where it mattered. It flew missions other aircraft could not fly, struck targets other aircraft could not strike, and survived in environments where other aircraft were lost. Crews trusted it enough to fly at 200 feet above hostile territory at night, in weather, at 600 miles per hour, knowing that their survival depended on systems that were revolutionary when they were designed and merely reliable by the time they matured. The F-111 earned its reputation the hard way, through operational success despite programmatic failure, and it stands as proof that even troubled programs can produce capable aircraft if given enough time, money, and determination. The Aardvark was never beautiful, never loved, and never quite what anyone wanted. It was, however, exactly what precision strike warfare needed at the moment when that form of warfare was being invented, and that counts for something.